Welcome to G Fun Facts Online. Have you ever wondered what's really flying the plane you're in? You see the pilots in the cockpit, but behind the scenes, there's a silent, invisible co-pilot at work, a digital ghost in the machine that has completely changed how we fly. Today, we're pulling back the curtain on fly-by-wire, the technology that turned aircraft from mechanical beasts into intelligent digital marvels. For most of aviation history, flying a plane was a workout. Pilots physically wrestled with yokes and pedals, which were connected to the wings and tail by a massive, complex network of steel cables, pulleys, and hydraulic pipes. It was pure mechanical might. But as planes got faster and bigger, this system became too heavy, too complex, and just couldn't keep up. The solution was revolutionary. What if you could replace all those heavy mechanical parts with simple electrical wires? This is the core idea of fly-by-wire. It translates the pilot's movements into electrical signals. Think of it as swapping out a bicycle's chain for a sophisticated video game controller. The idea was first perfected by the military, with the F-16 fighter jet being the first major plane to rely on it. But the game truly changed for all of us in 1988, when the Airbus A320 became the first commercial airliner to go fully digital, paving the way for every modern jetliner that followed. So how does this magic work? It's a constant, high-speed conversation. The pilot moves a control, maybe a side stick. Sensors turn that movement into a digital message. This message zips off to a set of powerful flight control computers, the brains of the operation. These computers don't just listen to the pilot. They're also getting constant updates from sensors all over the aircraft, monitoring everything from speed and altitude to the angle of the wings. The computers then think, okay, based on what the pilot wants and what the plane is currently doing, here's the perfect way to move the control surfaces. They send a precise command to an actuator on the wing or tail, which moves it just the right amount. Then, another sensor reports back, yep, command executed perfectly. This whole loop happens in the blink of an eye, creating a super responsive and incredibly precise connection between the pilot and the plane. Now, here's where it gets really interesting. The two giants of aviation, Airbus and Boeing, use this technology in very different ways, and it reveals a deep philosophical divide. Airbus sees the computer as the ultimate guardian. Their system has what's called flight envelope protection with hard limits. This means the computer will simply not allow a pilot to make a move that would put the plane in danger. No stalls, no extreme G-forces. If the pilot lets go of the side stick, the plane holds its course perfectly. The computer is the ultimate authority. Boeing, on the other hand, prioritizes pilot authority. Their philosophy is that the pilot should always have the final say. Their fly-by-wire systems have soft limits. They'll warn the pilot, they'll push back. But in a true emergency, a pilot can push through those limits and take full manual control. This difference is even reflected in the cockpit. Airbus uses a small side stick, while Boeing keeps the traditional, larger yoke to give the pilot a more direct, tactile feel. The benefits of fly-by-wire are massive. By preventing pilots from making catastrophic errors, safety has skyrocketed. Ripping out all that heavy metal for lightweight wires saves a ton of weight, which means better fuel efficiency. The system can also actively dampen turbulence, giving us a much smoother ride. But it's not a perfect world. The system's complexity means a software glitch, however rare, could be a serious problem. That's why there are multiple redundant computers running at all times. And in our connected world, cybersecurity is a new and growing concern. This has also sparked a debate. Are we making pilots too reliant on automation? Are manual flying skills fading away? The evolution is far from over. The next step is fly-by-light, swapping electrical wires for fiber optic cables. They're immune to electrical interference, even lighter, and can carry way more data. But the real sci-fi stuff is coming from artificial intelligence. Imagine an AI co-pilot that can learn from millions of hours of flight data to find the most efficient route in real time. Or a system that can detect a maintenance issue before it even happens. Researchers are even developing intelligent systems that could automatically compensate if a plane suffers damage. like losing an engine or part of a wing. These advanced systems are also the key to making those flying taxis, or eVTOLs, a reality, helping them navigate our busy cities all by themselves. So from the raw muscle of cables and pulleys to the digital brain of today's intelligent software, the story of fly-by-wire is a story of our relentless quest for safer, smarter skies. The next time you're cruising at 35,000 feet, remember the silent, lightning-fast conversation happening between the pilot, the computer, and the aircraft itself. A symphony of technology that truly keeps us flying.